Hello, my name is Professor TK the Chemist, and today we're going to get into a very interesting topic that deals with what, guys? Radioactive isotopes. Like, how are they even produced? Can you go to the grocery store and get some radioactive materials? Can you go outside and just inhale radioactive materials? Well, let's get into this lesson and find out. So, radioactive materials or radioactive isotopes are produced by a number of different ways. And what we're going to kind of look at today is how we can actually use that for further research. It is used for medicinal purposes. It's used for research, but there's a little bit of information known about radioactive isotopes simply because they're so reactive that by the time you try to grab one of them, they have already dispersed. They're already gone. And you can't really get as much information as you would like. So let's go ahead and dive a little deeper into what radioactive isotopes are, how they're produced. Did you know that many radioactive isotopes are produced in small amounts by bombarding stable, non-reactive isotopes with high-speed particles, such as the alpha particles that we discussed before, protons, neutrons, and small nuclei? Now, when one of these particles is absorbed, the stable nucleus is converted to a radioactive isotope and usually some type of radiation particle. Keep that in mind. Now, if you look at your periodic table, there are many elements on there. There are over 100 elements. But did you also know that any element that has an atomic number greater than 92, and 92 represents a wonderful year for me. More about that later. But anyway, do you all know that all elements that have an atomic number that's greater than 92 have been produced by some bombardment? That's right, y'all. Most have been produced in only small amounts, and they only exist for a small, short period of time. That's what makes it very difficult to study these properties. So, for instance, if we look at, let's say, californium-249, it's bombarded with nitrogen-15, and the radioactive element Wm-260 and 4 neutrons are produced. Let me go ahead and put this illustration on the screen right now. Hold tight. Hold tight. So here on your screen, you can see what happens when you bombard these atoms with radioactive isotopes. Here's the end result right here, okay? Pause the screen and come back and look at it. And let's keep it moving to the next example. Now, you've heard me discuss technetium-99M. Remember, the M stands for metastable, okay? That means that's the way that you can get that element to stabilize in that format by putting the M at the very end of that chemical or isotope notation. Now, technetium-99 is a radioactive isotope that is used in nuclear medicine for several diagnostic procedures. We've discussed this before. We can detect brain tumors, and we can also use that same radioisotope to examine the liver and the spleen. And the reason why this is the case is because it's able to target and hit those organs, and you can see it emitting using the gamma rays for imaging purposes, okay? And we'll talk more about that as well in an upcoming video.